Welcome back to your learning journey in the statistics and probability for data science. Now today, as we progress in this video, we'll be learning about as how we can implement the measures of shape in a hands-on manner using Python programming language. So it's a very interesting topic where you will learn in a hands-on manner what are the functions that are available to us. Now before that, it's very important that you need to understand as how you can access this code file. Now, as I mentioned repeatedly, if you are watching for the first time, so if you want to download the source code, just visit our course page, which is mentioned in the description. Just visit our course page if I want to show you about the same. So just go to our site manifoldailearning.in. Under the courses, there's a statistics and probability, which is a community course which we are currently learning. Click on the community edition course and here join now for free. Now once you join now for free, you'll be able to access all the course curriculum including the videos that I'll be adding over here. You'll be able to access the video curriculum as well as the source code over here under this specific LMS. Okay, so with this, let's get started and let's perform the coding in an hands-on manner. So now let's start by understanding and having a quick recap on this measures of shape. So measures of shape help me to get the overall distribution of the data set. Now under this measures of shape, so we have got skewness and kurtosis. If I specifically talk about this skewness, okay, skewness is a statistical term which will help us to estimate or measure the shape of my distribution. And here we will say the specific data distribution that we have got as a symmetrical when the left side is similar to my right side of my center point of my data distribution. And will call a data distribution as an asymmetrical when the left side part of the center of distribution is not same as the right side part of the center of the distribution. That is the overall difference between the symmetrical and asymmetrical data distribution. Now, when we are working and with this given data set and when we find the values of skewness is equal to 0, then data is normally distributed. And when I say skewness is greater than 0, so what is it when I have the value of skewness greater than 0? Yes, in such scenarios, we will have more weight in the left tail of the distribution. So more weight on left tail of distribution. And when I say skewness is less than 0, in such scenarios, I'll have more weight on right tail of distribution. So this is what we have got from our previous video. We know what exactly does this skewness value would indicate when we are working with the data set. Now let's go ahead and calculate it for a given data set. In order to find the values of skewness and even when we want to find the value of kurtosis, we'll be importing the library that is called as SciPy. I'll say import SciPy. Now once I do this import, let's get a dummy data. I'm going to create a data set is equal to, we'll generate some random numbers. So for that, I'm going to import my NumPy library. Now, if you're very new to NumPy library, do check out the NumPy playlist that we have got in our YouTube channel. So np.random 0, 100, let's say I'll have some 15 values to ensure the repeatability. Let's set some seed np.random.seed. Okay, next I'm going to display my data set. So I've generated the random integers between 0 to 100 and this data set got 15 values. That's what our data set has. Now let's go ahead and compute the skewness of this given data. Now in order to compute the skewness of this given data, we will make use of the function skew which is present inside the stats module. So scipy.stats.skew. Now inside the parenthesis, we will specify the data for which we want to compute the skewness. Now in this scenario, the data is my data set. So this is the data set which represents the elements that I've got right here for which I want to calculate the skewness. And then we have to specify the axis. So axis specifies the axis along which we want to find the skewness value. By default, it will be set as 0. So I'll just use the default value itself for our scenario. So I'll say axis is equal to 0. Now, apart from that, here we also have another parameter that is called as bias. So bias will help me to will help me to set the calculations, and it will help me to have the calculations corrected to my statistical bias. So that's the overall role of bias. I'll say bias is equal to true. Okay, by default bias will be equal to false. Now in the scenario, I'm going to set it equal to true. So when I execute this, okay, so it says scipy.stats. Let's do one thing. Let's import it in this way. From scipy.stats, I'll import skew. Next, I'll execute this. Now this should work. So we've got the output of skew, and here this time the value of skew that I've got is less than 0. So what does it mean? Yes, it means the data that we have got is negatively skewed data. This is a negatively skewed data. So this means we've got more weight on the right tail of the distribution. So this is how we are going to interpret from the value of skewness from the given data set. Similarly, when we talk about kurtosis is another statistical term, and here this we generally use it even for the data distribution check as well. So this will help us whether the distribution that we have got, whether it is heavy tailed in respect to the normal distribution or not. So here when we have the normal distribution, okay, in that scenario kurtosis will be equal to 3 for normally distributed data. Okay, and we will have the kurtosis less than 3, then in such scenarios it is so it's actually platykurtic, and if my kurtosis is greater than 3, then it would mean that the data that we have got, the distribution, it is leptokurtic. Okay, so this is the overall way that we are going to gain the analysis by calculating the kurtosis value. Now let's go ahead and calculate the value of kurtosis for a given data set. In order to do that, first let's just import the same. So I'll say from scipy.stats, I'll import kurtosis. Next, I'll use the same data set and I'll say kurtosis. Okay, and inside the parenthesis I'll specify my data set. Here, even in this scenario, we'll have to specify the value of axis. I'll set it equal to 0. And in this scenario, okay, so there's one more parameter that is called as Fisher. Okay, so here it's a Boolean value. We'll have to say whether it is true or false. So when it is true, it will calculate the Fisher's coefficient of kurtosis. If it is false, it is going to calculate the Pearson value. Okay, I'll keep the default value as it is. Okay, so I'll say, okay, let's do one thing. Let's specifically mention so that when you're referring the notebook, you will have the idea that you also have a option to change as well. Okay, so I'll say bias is equal to true. Now once I execute this, this will describe the value of kurtosis. Now in this scenario, the value of kurtosis is minus 0.97. Obviously, since it is less than 3, so I'll say that this data that we have got, this describes the platykurtic distribution. Okay, so as part of our learning journey in this very short video, we had a quick recap on the usage of skewness and kurtosis for a given data set and what it actually conveys. And we have implemented it with the help of Python programming language using the SciPy library. So with this, we come to the end of this video. Now, as we proceed in our next video journey, we will look into the measures of position. We will understand the measures of position, And as we proceed along, we'll also have an hands-on activity as well. So thank you so much for watching, and I'll see you next time. So if you're new to us, please consider subscribing.